Hi, my name is Spencer Janik, and I'm here to talk about the Busy Manager's Guide to Encryption. Just to review our agenda, to recap what we're going to be going over, first we're going to be talking about security and defense in depth, how we understand it at Amazon. Then we're going to be talking about envelope encryption, which is a particular cryptographic technique used by services in AWS. Then we're going to be speaking about asymmetric permissions, which are ways that you can configure your policies to isolate different components of your application or operators in your environment. And lastly, we're going to talk about client-side encryption and how you can build an application using the services we've discussed. So there's a related session that's also available on YouTube. If you search for the fundamentals of AWS Cloud Security, it was given and reinforced in 2019 by Becky Weiss. And she identifies three pillars of security in AWS, which are AWS IAM, which is the Identity and Access Manager, network controls, and cryptography. In that talk, she spends about 80% of her time talking about IAM, which is about right. We think that spending about 80% of your time talking about security, the roles that you're setting up and accounts you're setting up is the right way to think of it. But when you're interested in encryption, this talk is going to be helpful. So let's talk really high level about what is security. So broadly, the way that customers that I work with talk about security, think of it as a way of reducing risk. And the risks that customers are really concerned about are data exposure, when data is exposed to unauthorized parties, and loss of control, when the principals that are the authorized principals to control an application are the ones who are able to control it. And when we think about the types of risks that there are, we typically identify inadvertent risks, which are things that are misconfigured by mistake or things that happen inadvertently, and then malicious risks, where somebody is intentionally doing something wrong. So let's talk about defense in depth and what that means and how it applies. So defense in depth is a term that we use often in AWS. And you can imagine your application or resources as a castle. And in this castle, there's a moat around the castle. And the first moat that we generally talk about is physical access. So by building on AWS in an AWS region, your AWS region that you're building in comes with strong physical access controls to prevent unauthorized parties from getting access. So this is just something that you get when you're building on AWS, and we think it's a great part of the security matrix. Another layer that you're adding to prevent people from getting to the resources or applications or inadvertent exposure of your resources or applications is AWS IAM. Like I mentioned earlier, you can spend generally about 80% of your time reasoning about the roles that you have set up in IAM and how IAM operates for you to figure out how your security functions. Another layer in this defense in depth is network control. So if you have network controls on the endpoints that your internal principals use to access your applications or resources, that can be a powerful control to prevent users from inadvertent data exposure or loss of control. But you can also create resources like a VPC that will allow you to partition your network to reason about which users have access to which resources and applications. A lot of people say that cryptography is the last line of defense when it comes to security, but that's not really the way that we think about it. At AWS, we think of cryptography as a layer in the defense in depth model. So then, why encrypt? So there are three reasons why you'd want to encrypt your data. The first is that it helps keep data confidential, because when you use encryption to protect your data, then only users with access to the key have the ability to decrypt the data and have access to it. The second reason that a lot of customers encrypt is to demonstrate compliance. Whether compliance regime requires direct encryption or simply requires some sort of data control, that encryption is a control that will help you meet your compliance objective, encryption can be a powerful way to demonstrate that you're compliant with a particular regime. And then lastly, and this one, I got a little bit of pushback in for the original versions of this deck that I did. I think that cryptography, judiciously applied, can actually improve your organization's agility, because it makes it easier for you to think about what are the different components of my application, how do they operate, and who has access. The way that I think about this is paving the trusted path. So you often need to access data in your environment on both a read path and a write path. Whether your application needs to put new data in the cloud or to retrieve data from the cloud, you're constantly going to be reading and writing. So even though you have all these controls, you're going to have to pave a trusted path through those controls to make sure that the authorized parties have access to the authorized data at the right time. So looking at this from another direction, there is some particular user that would like to access a resource in S3. In this case, the user is always a set of credentials that are processed by IAM. In this case, we're using a helmet to signify a role. And so this particular user has credentials that are checked by IAM, and then let's say, for example, they're using a particular VPC endpoint to access a resource, so the policy of which users are able to access that endpoint is checked. And then they have a resource policy for the resource in the S3 bucket to determine whether or not that particular principal making a call has access. So you can think about this in terms of a permission model for S3. The logging is done by S3, and it's pretty low complexity because you've implemented a number of controls here. So let's talk about envelope encryption. When you have an object in S3 and you encrypt it, if you look at it from S3's perspective, it looks a little bit like this. There's an object that's encrypted, and then there's a key that encrypts this object. That key that encrypts the object is itself encrypted by a separate key. So when S3 needs to access this object, one of the first questions that it has is, what key was used to encrypt this key? So in order for S3 to understand what's going on with this object, some metadata has to be attached. And we call this an envelope. So if you were to look at the file structure, you'd see a very similar breakdown. The file contains metadata, an encrypted key, and encrypted data. Over time, businesses collect a lot of data, and so what you'll end up having in a system like S3 is you use server-side encryption is a number of pieces of data protected by data keys that are themselves encrypted. And you'll notice that there's a green key that corresponds to the green lock on these individual data keys that secure the individual objects. In order to maintain high availability, we recommend that you keep this green key in a service that is highly available and maintains high durability properties for your keys. If it integrates with AWS IAM, it's even easier. In AWS, this service is called the AWS Key Management Service, and it's what we recommend for protecting data that is encrypted server-side in S3. Let's take a look about the advantages that AWS KMS gives you. So looking back at the defense in-depth model we had earlier, where a given user with a set of credentials has their credentials checked, they're checked to make sure that they can access the particular network endpoint, and their resource policies are checked. KMS provides an additional layer of access permissions checking by having a key policy attached as well. So not only must the user have permission to access this particular resource, but because it's encrypted using a key that's in KMS, the user also has to have permissions to use the key to perform the decryption. So here we can modify our permissions model, where for server-side encrypted objects protected with SSE S3, the permissions model is S3 checks permissions, S3 does the logging, and it's pretty low complexity. If you use SSE KMS, for example, not only will permissions be checked at the S3 level, but also by KMS. And not only will logging happen at the S3 level, but logging will also happen in CloudTrail, specific to KMS. And the decrypt or encrypt request will be logged. And it's a little bit more complex to implement because you have to create a KMS key, but in general, we think it's a pretty good balance of complexity and security. So for the part of your application that is reading data to S3, and the part of your application that are writing data to S3 should have different permissions, which is why we have a concept called asymmetric permissions that we think is a powerful way that you can help limit risks to your application. So you've likely seen an IAM policy before. So I have one on the screen here. And you'll notice that in this particular IAM policy, it is allowing a particular principal to list keys and list aliases. What then does a key policy look like? Well, a key policy is identical. It's written in the same syntax, and this key policy allows a particular principal to list keys and list aliases for a key. There are additional controls that we can offer that are asymmetric. So now that we've covered what a key policy is and how it functions, let's dive into those. So this particular set of actions that we have on the screen right now is a set of administrative permissions. So users can take a look at a key, and the user who has these actions that are allowed in their IAM policy or key policy will be allowed to list aliases for a key, create keys, describe, enable, disable keys, etc. So it allows users to administer keys. You may be familiar with a role like this as being described as a crypto officer, because they have the ability to manage keys, but not necessarily use them. A separate user or account in the environment might have permission to use the keys. So here for these policies, you can see that there are certain actions that are allowed, like encryption, decryption, re-encryption, generating data key, etc. And also the allowing of attaching of persistent resources, which we call grants. Grants will be covered in a separate talk. So another way that you can create asymmetric permissions boundaries is by separating permissions to encrypt and decrypt. I mentioned earlier that there may be a component of your application that performs puts and another that performs gets, or writes and reads. Here, you can separate the permissions to allow one component of your application to encrypt data and another to decrypt data. And you can also set alerts, whether unexpected users are trying to perform functions that they aren't typically authorized to perform, which could be an indication of inadvertent loss of control or inadvertent exposure of data. But this way, if you isolate the components of your application and there's an issue with a part of your application that performs encryptions, then it's very likely that you wouldn't have any issues with the part of your application that would perform decryptions, and therefore service for your customers or your users wouldn't be interrupted, and you could resolve the issue without having to worry about overall application stability. One other way that you can help protect application stability and maintain strong permissions boundaries is through the use of client-side encryption. So as I discuss client-side encryption, the way that it works and the reasons why you might want to use it, keep in mind the security versus complexity chart that we had earlier. These situations aren't necessarily any more secure, but may add additional complexity. So that's the balance that we'll want to consider. In the example we looked at earlier, there was a user whose credentials are checked, who process data through a particular network connection, who access a piece of resource, or access a resource, in this case, an object in S3, and then have access to the plain text data. However, ultimately, let's say, in this scenario, that the resource is received by an application running on an EC2 instance. On that instance, how can we add an additional layer of security control? Let's say, for example, that my application accepts resources that users upload. For example, a driver's license photo. So an end user has a browser, and they want to get this piece of data into my application. But I have another application that is run either by a partner or is a service that I pay for that is running within my VPC. But I don't want this third party to ever have access to the important data like a driver's license photo that users are uploading. In this case, you can use a piece of software like the AWS Encryption SDK to request a key directly from KMS to the user's browser to perform the encryption on the object as it's uploaded. Then, when the object is shared with the application, even if the third-party application or service that I'm working with is at the very front end of my application that receives data from the user, because it was encrypted client-side, the third party has no ability to access the plain text data unless they have access to the key in KMS. But when that piece of data gets to my EC2 instance, where my application is running, that application has permissions to access the key. So it makes a request to KMS to decrypt the key, decrypts the piece of data, and then, if I need to store the plain text data in S3, my application can do that. And I don't have to be concerned about the third party that's operating within my space or a less trusted component of my application having access to sensitive data. So again, looking at the chart we discussed earlier, that the permissions model for SSE S3 for standard server-side encryption is permissions checked by S3 and logged by S3, and the complexity is fairly low. On the other end of the scale, we have SSE KMS and also client-side encryption, which does add complexity to your application because you have to configure your end user environment to have additional software, but it gives you the added benefit of an additional layer of permissions checks, which for some scenarios is useful. Lastly, we're going to talk about how to build an application using AWS cryptographic services. So let's imagine a typical application where an end user accesses an application that makes a call using an application load balancer is distributed to an EC2 instance, that then has to make calls of both an RDS database and an S3 object store. So if I have developers that need to access this EC2 instance, perhaps they're managing keys on their own. If that's the case, then it's possible that those keys could be inadvertently exposed. And if that's the case, we'd want to lock those down. So EC2 offers a feature called EC2 Instance Connect that will manage keys on your behalf to make it easier for you to get access to your instances without having to worry about developers managing their own permissions. As long as they have credentials to access their user account within AWS, they'll have permissions to access the relevant instances. Next, let's take a look at S3. The objects that are in S3 are currently in plain text, which means anybody who has access to the S3 bucket will have access to the objects. But we can use SSE KMS in order to maintain a security boundary around those S3 objects to allow an additional permissions check for users who want to access the resource. How about the application load balancer at the front end of my application? Well, to make sure that the user is calling the appropriate application and the appropriate entity that they plan to be contacting, we can use AWS Certificate Manager and drop a certificate on that load balancer. That way, when the end user is making a request for the application load balancer, they can check the certificate in the browser that they're receiving from the application to determine whether or not the identity of the application matches the application that they're thinking that they're contacting. It's an additional layer of security using asymmetric cryptography that allows users to understand the identity of the organizations that they're interacting with. Now let's take a look at credentials. So on our EC2 instance that we're running an application, we have an RDS instance that we're connecting to. And so on the EC2 instance that's running our application, we have, let's say, stored in memory some credentials. So like a username and password to access a particular database. In this case, that password might be vulnerable because if a party got access to that EC2 instance, regardless of what their account was, then it's possible that they could also get credentials for a database that would contain access to other data that we wouldn't want them to have. Or in an inadvertent exposure of data, it could be misconfigured. So those credentials could be wrongfully exposed or corrupted in some way. AWS offers a service called AWS Secrets Manager that allows you to store OAuth tokens, database passwords, and other secrets that you need in your environment so that they can be programmatically accessed by your application and by your developers. AWS Secrets Manager provides secrets that are encrypted by keys that you can manage in the AWS Key Management Service, and also supports rotation by default. So if you need to frequently rotate your credentials, you can do so using Secrets Manager. So now let's take a look at, and you can see here on the chart that there's a relationship between AWS Secrets Manager and the AWS Key Management Service. So looking at the AWS Key Management Service, currently the AWS Key Management Service uses hardware security module devices that are validated at FIPS 140-2 Level 2 overall. Some customers, because of compliance use cases, require HSM devices that are certified at FIPS 140-2 at Level 3 overall. In those cases, you can also use AWS CloudHSM to create a single tenant HSM device that you can connect to AWS KMS and use to store your key material. The connection between AWS CloudHSM and AWS KMS is known as Custom Key Store, and it's a feature that allows you to connect a single tenant piece of hardware managed by CloudHSM with the AWS Key Management Service. Thank you for stopping by and listening to my talk about the relationship between different AWS cryptography services and tools and techniques you can use. I'd like to leave you with this quote from Jean Baudrillard, that nothing is wholly obvious without becoming enigmatic. So thank you so much for attending the talk. Please remember to complete the session survey. Thank you.